The only way to really learn the chain rule is by practicing. So let's run a few examples. I have starting with h of x equal to a composite function. I hope you see this quickly by now. There's x squared minus 1, simple one, and the whole thing squared. So you have choices, by the way, often, but in this case I would define the inner function to be this one. G of x is x squared minus 1, and the outer function is simply the square. So just think of this as dot dot dot, or as we've done before, we just call this z. So this is z squared. You have to, when you define the outer function, you replace whatever is g of x by a placeholder, and you can call that placeholder z or parenthesis or empty parenthesis as you wish. Now, this means that f prime of z is simply 2z. And now remember, z is a placeholder, so in the final chain rule, we now have to plug g of x back into z. So that means that f prime evaluated at g of x is 2 times, and now instead of z, this should be g of x, which is x squared minus 1. And g prime of x, simple g prime of x, is just d dx of the inner function, which leaves you with a 2x. So combined, that means derivative of h of x. So if you combine all this together, that means h prime of x is outer times inner. What is outer? That was 2 times x squared minus 1 times the inner derivative, which is g prime of x, times 2x. Or, putting terms together, that's 4x times x squared is 4x cubed minus 4x. A new example. H of x equal to e to the x power 4 minus x. Now let's see, what could we define as inner and what's the outer function? Again, an easy choice. I would define this as g of x, and the e function by itself is f of, again, you can call this z. So that means that f prime of z is just e to the z again, means that f prime evaluated as at g of x is the full original function unchanged. So that is e to the x4 minus x. And g prime, x equal to, what is it, 4 times x cubed minus 1. So putting it all together leaves us with h prime of x, outer times inner. We've just learned that outer is this factor, e to the x4 minus x times, and again I should probably put parentheses around this, times the inner, which is written up here, 4x cubed minus 1. And now if you didn't put brackets around, you would have an incorrect result. That is the proper way of writing it. This means that the exponential multiplies both this term and that. As a final example, we are taking the natural logarithm, this is the natural log, as an outer function, and another polynomial as an inner function. Write this the way we've written it before. This would be our g of x. Derivative of that is simple. G prime of x is simply 3 times 3 is 9, x squared, and the minus 1 falls away. Now ln is our outer function, so f of z is equal to ln z. Yeah, z is a placeholder. Ln z. It follows, pardon my z, it follows that f prime of z, remember the natural log is a special derivative, and the derivative of that is just 1 over the argument. Now let me put that together on the next line. That means h prime of x is outer times inner. Outer would be 1 over z, but the z has no business anymore. We have to replace z by what? By g of x. There goes my 3x cubed, the original function, minus 1. 1 over z and 1 over g of x times the inner, times 9x squared. And of course, I can write this as one fraction. That is the same expression.